Hi, I'm Tom Vladeck, co-founder and co-CEO of Recast, the platform where the most advanced brands measure, forecast, and optimize their marketing spend. Today, I'm going to talk to you about the interaction between upper funnel and lower funnel channels in the context of a media mix model. Upper funnel channels are things like TV, out of home, radio, podcasts. These are the kinds of channels where you are generating awareness, introducing your brand, reactivating customers that may already be aware of you, reminding them that you exist. These channels are typically capped by your budget and your willingness to spend into those channels. Lower funnel channels are things like branded search on Google or in the iOS store. These channels depend on people searching for your branded keywords. They are driven by upper funnel activity. Say you run a TV spot, you introduce somebody to your brand, they type your branded name into Google, and they are served a branded search ad. That would be a typical journey that would induce some of this branded search spend. Anytime you have an interaction like this, whether in the context of media mix modeling or elsewhere in statistics, it's important to think through how the system works qualitatively before you start doing any quantitative modeling. As I will show you in the following exercises, if you don't account for this dynamic, where your upper funnel spend causes lower funnel spend, your model is almost certainly going to be wrong. The right way to do it is to use a hierarchical approach. For those true Bayesian stats nerds out there, this is going to be a slightly different take on a hierarchical model than you may be thinking, but it's still hierarchical in its approach. I'll walk you through exactly how we arrive at that conclusion and what we do to solve for it. So right now, you are staring at a screen of Daggity.net. Daggity is a play on the acronym Directed Acyclic Graph. One half of the causal inference community loves to use directed acyclic graphs as a tool for causal inference because once you set up a DAG, you can use some analytics tools to tell you if you've set it up correctly in order to estimate the causal effect that you're interested in. Right now, we have a very simple DAG that we'll use today, which has three variables. Upper funnel channels, remember, think something like TV. Lower funnel channels, think something like branded search, and sales. So we're going to start defining these variables. Sales is the outcome that we are interested in. And these all went blue because they are ancestors of the outcome, meaning they are upstream of it. Now let's define upper funnel channels as my exposure. Great. No open biasing paths for the total effect. Now, if I want the total effect of upper funnel channels and I simply include upper funnel channels in my regression and sales as the dependent variable, I will get the total effect. However, if I adjust for lower funnel channels, meaning if I include them in the regression too, I have a problem. This model will be incorrectly adjusted. If I want the total effect of upper funnel channels and I also include lower funnel channels in the model, the problem is that some of the effect of upper funnel channels is by causing branded search spend to go up, which then causes some people to purchase the product. So there is some indirect effect here that is no longer going to be correctly assigned to upper funnel channels because they're going to be captured by this lower funnel channels term instead. So that is a problem. Now, if I want the direct effect, no problem. I can capture that here. Now, what if I don't adjust for lower funnel channels and I leave them unadjusted? Well, if I want the direct effect of upper funnel channels, now I can no longer capture it, right? If I just include them in the regression and don't adjust for lower funnel channels, now I won't be able to, right? So the problem is that my regression is only going to give me one term out of the two that I might be interested in, depending on how I adjust for lower funnel channels or not. So this is a problem. How do we get around it? That's what I'll show you next. I have a very long R script here, and I am giving away the results. So I'm going to clear that plot. If you saw it and you were able to interpret it in time, kudos to you. Let's set things up here. Okay, so I've loaded some libraries, and let's say I want 1,000 time steps. So the first thing I'm going to do is I'm going to simulate our predictors, which are going to be marketing spend. As in the previous working session, I've done this in a sort of easy way, right? So I've generated a random normal variable. I've taken the cumulative sum. This will be a random walk. Then I've put it through the inverse logit function, which will bound it between 0 and 1, and then I've scaled it. When I do that, I get a bounded random walk that will look like this, right? Now I'm going to generate some ROIs, direct ROIs for my upper funnel channels. I'm just drawing a random number between 0 and 5 for these two channels. So this is beta 1, beta 2, and they're going to get multiplied in the data simulation function by x1 and x2 respectively. These are the direct ROIs on upper funnel channels. Now we have the lower funnel induced spend. So for every dollar of my upper funnel spend, how much lower funnel spend am I driving? I've decided to use this exercise with 2 upper funnel and 2 lower funnel channels, right? So there are going to be 4 effects. There's the effect of the first upper funnel channel on the first lower funnel channel, the first upper funnel on the second lower funnel channel, and so on. I have these 4 variables representing that induced spend. I can create them, boom, 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 boom. And then finally, I'm going to simulate the lower funnel spend here. So in X1 and X2, my upper funnel variables, think TV, podcast, the randomness here is really due to how the spend that you decided it would be spent is flighted. You decide how much you're going to spend on TV, how much you're going to spend on podcast, and there's some random variation there. Whereas with lower funnel spend, much of the variation is going to be driven by what you did in your upper funnel programs. And so we can see that dependence here. The lower funnel channels have their own ROIs. So branded search might have some large effect or it might have a small effect. We don't know. We'll simulate it and find out. But these ROIs also matter to the prediction function. So finally, we will simulate an outcome. So we spend X1 and we get beta 1 direct ROI. We spend X2, we get beta 2 direct ROI. Spend on lower funnel some amount, S1, and we get some lower funnel ROI, and so on and so forth. And so we can simulate this and we get some relatively reasonable path of sales, right? This is all simulated. So the question here to think about is what is the total ROI of channel 1, X1? Now this is a slightly more complicated thing that you might think, right? If I spend more on TV, I have to account for that spend, right? But I also have to account for the induced spend. I can't just evaluate the effectiveness of my upper funnel channel based on what it alone does. I need to account for how much I spent on TV and how much it led me to spend on branded search, how much direct effect I got from TV, and also how much indirect effect I got from branded search and any other lower funnel channels I may have. So the total ROI of X1 is actually going to be slightly more complicated than just extracting beta 1 out of the equation. The total ROI has some indirect effect that we have to account for, and then it will have a total effect, an indirect spend, and then the total ROI is the total effect divided by the total spend. And this 1 here is because this is indexed to $1 of spend, $1 of spend in your upper funnel channel like TV. We're capturing the indirect effect here. So this is 0.52. So if my ROI were 1, my direct ROI were 1, direct ROI is 0.93. My indirect effect is a meaningful portion, in this simulated case, of the total effect of an upper funnel channel. The total effect here is 1.45, roughly a third of it coming from this indirect effect, which is the lower funnel channels. And then the indirect spend is also something we care about. Indirect spend is going to end up being about a third of the total equation here, right? 0.52. And so the total ROI is going to be 0.95. Now in this particular case, the naive ROI, which is just beta 1, is going to be actually pretty close to the correct ROI. That can happen. Let's see what it's like for channel 2. I'm capturing the indirect effect, which leads me to capture the total effect, the indirect spend, and then the total spend, which is down here, and then I get a ROI. Now, in this particular case, we come off it way wrong. Our naive ROI is 2.52, but the correct ROI is 1.4, much lower. Why is that? The indirect effect here is 0.86, and the indirect spend is 2.32. Most of the spend here that we have to account for is induced lower funnel spend. This particular channel is really effective on its own, but it's also driving a lot of additional spend into lower funnel channels that is less efficient. On its own, it's very efficient, has a very strong direct effect, but it is driving less efficient spend into lower funnel channels, bringing its overall effect down. If you were to naively estimate or be given the direct effect, you might think, wow, 2.5x, that's great. But the actual total effect is much lower, 1.4x. So let's see what happens when we try to capture these numbers by using a regression. And I'm only going to do ordinary least squares here because we've set up a very simple linear equation here, so it should all work, right? But let's see what happens when I do that. Okay, so I have this naive regression with all of the channels included, and I'm going to pull out the estimates. You might wonder what this -1 is for. Well, that's the intercept. We don't particularly care about it right now. And so I have the estimated ROIs for X1, for X2, for lower funnel channel 1, and for lower funnel channel 2, right? And they correspond with the 2 upper funnel channels that I have in the model and the 2 lower funnel channels that I have in the model. Well, how do we do? The estimates really line up closely, right? The estimates and the direct ROIs are very good. We have almost no issue here because we've set up the model, the regression, and it's basically line for line or element for element with the equation that generated the data. But the question is, do we capture the total ROIs? And we don't. This is what we saw earlier. The estimate is 2.5x. The actual is 1.43. The reason is that this particular channel is driving a lot of relatively inefficient spend into lower funnel channels, and so its actual total ROI is much lower than you would estimate with this model. What are we going to do? Here's another approach you might take. You might say, okay, these lower funnel channels are causing a serious problem. Let's just remove them from the regression. So this is a model with the upper funnel channels only. And again, we're pulling out the intercept so we can look at the coefficients of this channel. Great. And we get X1 and X2. How do we do? Well, we do pretty bad, right? Let me label these. So the estimates here, I'm going to just do this for all of them. Boom, 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 boom. Okay, so we looked at the estimates and we're comparing them with the direct ROIs. These are the coefficients out of the model, and these are the direct ROIs. We don't come close to capturing them, right? The estimate is way off on the second channel. We're guessing a direct ROI of 4.13, but we actually have a direct ROI of something like 2.5x. What about with the total ROIs? Well, we're still estimating 4.13. The direct ROI is even less than it was before. We estimated it. The total ROI is 1.4. So our error, our estimate of the thing that we care about has actually gotten worse. Now we might be thinking what's in this model is the total effect, right? But not really. That's not what's coming out. Something totally different is coming out of this model. And so it's not representing anything we particularly care about. It's not the direct ROI, it's not the total ROI, nor the total effect. So sometimes even very simple models can sort of flummox you. I'm going to show you the approach we use at Recast, obviously highly simplified, that uses a hierarchical approach, meaning there are actually multiple models here, and that adjust for everything along the way to capture all of the effects we care about, and we can actually recover the right numbers. The first level in the hierarchy is to regress spend on spend, regressing this lower funnel spend on the upper funnel channels. We're saying how much of this channel spend was driven by these upper funnel channels. And so these are these two models. And then finally, the last model is the model that we ran before, which is just our sales vector on all of the channels, upper funnel and lower funnel together. Now, in the next several lines, I'm going to be taking the estimate of the things that we computed directly above and see how close we did with this model. So the estimate of the indirect effect of channel X1. What's going on here? So first of all, let's look at mod S1. Mod S1 is driving the first lower funnel channel spend. We get an estimate slightly negative here. That doesn't make a lot of sense, but remember we're using ordinary least squares. That can happen. So for every dollar, we actually spend less in the lower funnel channel. For every dollar of X1, we spend slightly less on the first lower funnel channel. And for every dollar of X2, we spend about 50 cents on the lower funnel channel. And so for the indirect effect of X1, we are pulling out this second number here, and we're multiplying it by the fourth coefficient on our sales variable. So we are saying the indirect effect of channel X1 is how much of lower funnel channel 1 did I drive, and what effect does that channel have? So we're pulling out this number, and we're pulling out this number. Now the second thing we need to do is we need to do it for this second lower funnel channel. So the second lower funnel channel is going to look like this, these coefficients. For every dollar of X1, we spend about 13 cents on this lower funnel channel. So we're pulling out this coefficient and this coefficient, which is the fifth of this model. That is going to give us the indirect effect of channel X1. What about the indirect spend? Well, it is just what we showed before. It is the first regression up here, this term in this model, and then this term in this model. For every dollar of channel X1, we're actually spending slightly less into the lower funnel channel S1, and for every dollar of X1, we're spending about 13 cents into lower funnel channel S2. The indirect effect is about 12.5 cents, and the indirect spend is about 11.5 cents. The total effect is the direct effect plus the indirect effect. Finally, we get the estimated ROI, which is the total effect divided by the spend you put into the upper funnel channel, which is 1, plus the indirect spend. We get an estimate of the ROI for channel X1 at 0.958. Now we basically just repeat the same logic to get ROI X2, and we get 1.45 as our estimate, right? That is the estimate based on this hierarchical approach of the ROI of channel X2. So that was all very confusing. So I've done some data manipulation here to set it up. I have a variable I, the index. Sort of ignore these errors. I don't know what R is doing to me, but we can see in the data what's going on here, which is that the actual is 0.95. The upper funnel channel approach gets pretty close. The all channels approach gets really close. The hierarchical channel gets really close for channel X1. Great. For channel X2, the actual is 1.43. The upper funnel approach vastly overcredits this channel. The all channels approach also overcredits this channel to a less degree, and the hierarchical approach basically nails it. Eagle-eyed viewers saw that I set the seed here to 1, so you might be wondering, was this all just lucky? What I've done here is I've written a function that is just going to do the whole thing over again and return this data. If I hit this, it'll run 1,000 replications of this simulation with different random data, run all the regressions, and see how well we do. So I'm going to sit back, relax, let the compute cycles do their thing, and in a moment or two, this will be done running, and then we can check to see how well everything did. All right, so just to give you a sense of what this looks like, so we can see channel X1 in the first replication, I've subtracted the actual estimate, the estimate that we know is true. So all of these errors are indexed to the actual value, right? So this negative value means that the actual was greater than the estimate, right? So a negative value means we undercredit it, and a positive value means we overcredit it. Is that right? Yes. So a positive value means we overcredited it, and a negative value means we undercredited it. It can be hard to keep track, but I got there. So we have 1,000 replications, 2 channels, 2,000 rows of this data set, and to summarize it, I've just piped it into ggplot to show a box plot across all of the different approaches that we've shown. And here's what we see. So I have the 3 approaches across the left. So I have the all channels approach, the hierarchical approach, and the upper funnel only approach, right? 0 means we nailed the estimate. The actual ROI was 5 and we got 5. The error is indexed 0. The upper funnel channel approach is vastly overcrediting the upper funnel channels, right? If we only include upper funnel channels in the model, we are likely to get overly high estimates for the effect and the ROI of upper funnel channels. However, if we include all of the channels in the model, we get the opposite error, although to a smaller degree. We are likely to undercredit upper funnel channels. If we use the hierarchical approach that I just showed, we are likely to get very close. This is unbiased. Now, of course, there's random noise we're going to miss it, or in this approach, you're going to miss it some of the time, but we're going to have much tighter error, and we're going to be unbiased around the true value, which is what we ultimately care about. Just to bring it back, this is a really simple DAG, right? There are only 3 variables. In the true media mix modeling world, there's many more factors to consider. There's things like brand awareness or seasonality. The actual true DAG that we're trying to model is much more complicated than the one you see here, but hopefully, as this exercise shows, even very simple models of the world can lead you astray if you don't really think through them. In this particular case, it's a case that every marketer knows about. When you have upper funnel channels that drive awareness and drive activity in other channels, if you're not accounting for it properly, you are going to get biased estimates of the effect, either biased high or biased low. The only way to get an unbiased estimate is to model this dynamic hierarchically, to directly model the effect of upper funnel channels on lower funnel channels, and then to incorporate those estimates into your total ROI estimates for upper funnel channels. That's the only way to do it that we know of. But if you don't do something like that, and you either include all of the channels in your model, or you only include the upper funnel channels in your model, and you look at those results without adjustment, you're going to get biased results. This is a particularly simple part of the total directed acyclic graph that shows all of the qualitative relationships that we as Recast, we as marketers, we as statisticians care about modeling. So when we are adding new elements to the statistical model, this is the first step. Very carefully look at the causal relationships, the qualitative nature of those relationships, and think carefully about what we want to include in the model, what we don't want to include in the model, how we should adjust for things if there are secondary or tertiary elements of the model that we need to include in order to capture the right effect. Because as we see, even in a simple sub case of doing it the wrong way can lead to biased results, something that we desperately want to avoid. Thank you very much.